Hello guys, welcome to Python Joe. Today we are doing a project on food recognition, nutritional facts and calorie count using machine learning. This project is about fruit, vegetable classification. It's a simple web application that takes the image of a type of food, specifically a fruit or a vegetables, such as a mango, apple or an orange, and utilizes a pre-trained model to identify, categorize, for example, fruit or vegetable, and provide the calories and nutritional information concerning the food. So in this project, the tools used, which will be shown later on, are Keras, Pillow, and Streamlit, and NumPy. So Keras is used for model creation and object prediction. Pillow has been used for image pre-processing. Streamlit has been used for the front end. The front end of the project was made using Streamlit framework. The NumPy has been used for image matrix handling. So the model used here is a MobileNet v2 architecture, which is a neural network architecture. So it's a pre-trained model that has been used here, and the pre-trained model is the MobileNet v2 architecture model. So the workflow of this project involves the user uploads the image, then the image is stored in the local system. Then the framework Pillow will resize the image according to the model shape that is accepted, according to the shape that is accepted by the model, and then it converts it into a vector. So this vector gets passed into the model, and then it's classified. So after the classification of the image, we get the ID of the image, the classification, whether it's a vegetable or a fruit, then finally the calories and nutritional information. All the results will be taken, compiled, and will be displayed on the screen. So the accuracy of the model turned out to be 96%, and here is the visualization. Now let's go straight to the project. So this is the directory of the project. The first folder here is the dataset folder. In the dataset, we have the dataset that was used to train the model. So the dataset was divided into train, test, and validation. The test was used to test the model, train was used to train the model, and validation would be used for testing the model later on in the web application. So this is the folder that carries the image that has been used in the front-end application. So in the front end, once the front end has been displayed, this is the image that appears, the image inside this folder. So once every image that has been scanned, that has been uploaded onto the model, that has been passed through the model, is saved here in this folder called upload images. So these are the images that have been scanning ever since I created the model. So here is the virtual environment. This folder contains the virtual environment, whereby all the frameworks have been installed that will be needed, all the dependencies, all the requirements needed to run run this project. They have all been installed in this folder. So this here is the front end. Is the code, Python code for the front end of the project, and here is the overview of the project. Our model is here. It's in binary code, so it can't be opened. It can only be understood by the CPU. Finally, this is the Python notebook for the the Jupyter notebook for the whole project that was used to train the model and do the evaluation and visualization and everything. So here are the requirements. So for you to run this project, here are the requirements that needs to be satisfied. You need to satisfy all of this before running the project, but in our case, all the requirements have been satisfied inside this virtual environment. So for you to run the project, you need to come here and go straight to the command prompt. Once you're at the command prompt, since our project has been saved in the virtual environment, first of all you need to navigate to the virtual environment. So for you to go to the virtual environment, you need to key in the code, the above code. So the name of the virtual environment, scripts/activate. So once you type in the code, you are in the environment, and for you to know that you are in the virtual environment, this one comes up, the name of the environment enclosed in brackets. So for you to run the front end code, you need to invoke the code using this command. So Streamlit run, then the name of the file app.py. So after you type in the code, press enter, then after some time it will take you direct to the browser. Now that's the advantage of Streamlit. Yeah, it takes you direct to the browser. Then once you're in the browser, after some time the code will run and come up with the front end. So the benefit of Streamlit is that number one, it is fast, it's reliable, and it's lightweight. So unlike other frameworks, Streamlit, you don't need to copy and paste your link to the browser. Once you type in your code here in the command prompt, Streamlit will directly take you to the browser, as you are seeing here in the video. So it takes some time. As you can see here, it's running. So after running, it will bring in the front end code, the front end web page that the end user will interact with. So just give it some time. So it's going to run for some time. Then after it runs, we are going to interact with our model via the front end. So here it is. First of all, we come across this the title of the project. Then here is under this template, this is where you interact with the model. So first of all, you need to browse for images. So for the images, we are going to use the validation. Come here to the dataset, choose a random image, of course your designed image. Then it's going to scan the image and come up with the results in a few seconds. Yeah, so the image has been resized, and here are the results. It has been categorized as a fruit. The ID has been predicted to be a banana. Then the calories have been predicted to be 89 calories per 100 grams of the banana. And the nutritional facts are this banana is high in potassium, vitamin B6, and it promotes heart health, and aids in muscle recovery. Thank you for your time. Have a good day. If you want to get more information on this project, the link is down in the description box below the video. Thank you.